Hello, I hope everyone is doing well today. Today we're going to talk about graphing rational functions in the form of f of x equals p of x over q of x. When we are graphing functions in this form, it is important to note that p of x and q of x share no common factors other than positive or negative 1. Each graph of this form has three specific characteristics. The first being that the x-intercepts are the real zeros of p of x. The second characteristic is that the vertical asymptotes occur at the real zeros of q of x, and the third and final characteristic is that the graph has at most one horizontal asymptote depending on the degree of p of x and q of x. If the degree of p of x is less than the degree of q of x, the asymptote is the line y equals 0. If the degree of p of x is equal to the degree of q of x, the asymptote is the line y equals the leading coefficient of p of x divided by the leading coefficient of q of x. And if the degree of p of x is greater than the degree of q of x, there is no horizontal asymptote. Please take a moment to pause this video and record these characteristics in your notes. Now let's take a look at the example f of x equals the quantity of 2x squared minus 5x plus 2 over the quantity of x squared minus 9. The first thing I'd like to do is find and plot the x-intercepts. Remember, the x-intercepts are the real zeros of p of x, or the numerator of our function. Looking at my numerator of 2x squared minus 5x plus 2, I would first want to factor it using the diamond method. I'd be looking for factors of 4 that sum to negative 5, which would be negative 4 and negative 1. Then going to my area model, I would put my 2x squared in the top left box and my 2 in the bottom right hand box. The remaining two boxes would be filled in with the negative 1x and negative 4x I found in my diamond. Now looking at the greatest common factor of each vertical and horizontal pair of numbers, I would find out that between 2x squared and negative 4x, the greatest common factor is 2x. Between negative 1x and 2, the greatest common factor is 1. Between 2x squared and negative 1x, the greatest common factor is x. And between negative 4x and 2, the greatest common factor is 2. When I go through to check the area of each individual box, I would find out that I would have to make my 1 and my 2 both negative. Therefore, my numerator would factor into the quantity of 2x minus 1 times the quantity of x minus 2. Using the zero product property and setting each of those factors equal to 0, I would find out that I get x is equal to 1/2 and x is equal to 2. Then I would go to my coordinate plane, and now that I know my two x-intercepts, I would plot them on my graph. Please take a moment to pause this video and record what we have done in our example thus far. Now that we have found and plotted our x-intercepts, we want to find and draw our vertical asymptotes. Remember, the vertical asymptotes are the real zeros of q of x, or our denominator. Looking at my denominator of x squared minus 9, I realize that it's the difference of two squares, so I know that it factors into x plus 3 times x minus 3. Using the zero product property to find the real zeros, I would set each factor equal to 0 and solve. When I set each factor equal to 0 and solve, I get x equals negative 3 and x equals 3. Going to my graph, I am now going to draw my two vertical asymptotes of negative 3, x equals negative 3, and x equals 3. Please take a moment to pause this video and record our second step of our example. Our third step would be to find and draw the horizontal asymptote if it exists. Remember, if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Although looking at our example, our degree of our numerator is 2 and the degree of our denominator is 2. Since the degree of the numerator and denominator are equal, the horizontal asymptote is the equation y equals the leading coefficient of the numerator, 2, over the leading coefficient of our denominator, 1, or y equals 2. So I'm going to go to my y-axis and draw in my line y equals 2. Please take a moment to pause this video and record the next step in our example. The next step to graph our example is to find and plot several points beyond and in between our vertical asymptotes. Since I have a vertical asymptote at -3, I'm going to choose to plug in the values of -6 and -4 for x. When I plug in -6, I get an output of 3 85/100ths. When I plug in -4, I get an output of 7 71/100ths. So I'm going to go ahead and plot those 2 points. Now, I also have an asymptote at the line x equals 3. So if I want to plug in some values in between them, I'm going to choose to plug in the values of -2, 0, and 2. When I plug in -2, I get an output of -4. When I plug in 0, I get an output of -22/100ths. And when I plug in 2, I get an output of 0. So now I'm going to take a moment and plot those points as well. Now, choosing 2 values beyond my asymptote of x equals 3, I'm going to choose to plug in the values of 4 and 6. When I substitute 4 in for my input, I get an output of 2. And when I input 6, I get an output of 1 63/100ths. So now I'm going to take a moment and plot those 2 points as well. Once I've plotted all of my points, all I need to do is connect them and remember to draw my lines getting close to and approaching my asymptotes. Once you have connected all of your points, you have completed the graph, and the final step is done. Take a moment to pause this video, finish recording the example, and write down any questions that you may have for when we meet in Zoom shortly. Have a great day.